Greetings to our panels, especially to our chairman, Engineer Helen Gonzalez. We, the researchers, will discuss about our thesis study entitled Design and Development of Portable Wave Electric Power Generating Device. Due to rising global power consumption, pollution, and global warming, non-polluting and long-lasting energy sources are required. Wave energy is most promising type of energy source. Wave power is a type of energy creation in which the energy stored in tidal waves is utilized to power an engine motor, which generates electricity. The existing wave power generators are the PB3 power buoy from Ocean Power Technologies or OPT, the SETO wave energy system, and the Echo Wave Power. This study seeks to develop the design, setup, and performance of a portable wave electric power generating device. This generating device is considerably small compared to the conventional wave power generator. The researchers aim to relatively reduce this wave power generator down to a size that may be used in a community without sacrificing the power production, which could be enough. In addition, develop a cost-efficient motor generator that would be worth in the long run.
Statement of the problem. The study specifically is about developing the portable wave electric power generating device. This will adhere and solve problems in electricity since power interruptions are common in the Philippines and the electricity costs are high. The following questions were considered throughout the preparation of this study. First, what design parameters should be considered to develop the portable wave electric power generating device? Second, what development strategy should we adopt to be utilized to ensure that the portable wave electric power generating device will work? And third, what evaluation parameters should we assess in order to measure the performance and acceptability of the portable wave electric power generating device?
The brief of this research seeks to develop the portable wave electric power generating device to be made susceptible in providing sufficient power and safe to use. Here are the particular objectives of the study. To design relatively susceptible in providing sufficient power of wave power generator, to develop a wave power generator with necessary equipment, and to evaluate and measure performance and acceptability of the wave power generator.
Significance of this study. So the significance of this study is to develop the current wave power generator into being cost effective while still meeting a sufficient output need. This will be beneficial to the following. So here in Philippines, portable wave electric power generating device can be one solution to minimize costs, especially to every electric corporations in the Philippines that adheres to the national grid. So in every community, this study will help communities in their electricity problems with regards to the sudden power interruptions that affects their daily lives. So in instructors, the study will be greatly beneficial to them as this will give them information and insight about developing a portable wave electric power generating device that they will actually impart towards their students. So in students, the study will be beneficial to the students, especially to those who take up electromechanical technology, as they are the one who will be future developer of such machine. So in future researchers, this study will be served as a reference for researchers on the subject of research in the field of electromechanical technology. This will serve as guides to further develop the research with connections to wave generator.
Conceptual framework. The researchers use the input process output relationship for conceptual framework. Under input is baseline research, guideline process, and knowledge and skills. Under process is machine design, development, and testing, while under output is completed and evaluated prototype. Scope and limitation. This study focuses on generating a power output of 100 watts 24 volts and 4 amps of current from a small-scale wave generator for convenient purposes. This is done by constructing a prototype test to determine every value of power a single construction produces and the average value from the total constructions. The motor design in connection with this project is based on the features of earlier designs. This study is only limited to the factors such as strong winds and waves. More so, high tide is also an additional aspect. Scope.
Review of related literature. Wave energy converters are classified in three sections where the average and exploitable amounts are indicated as a percentage of the maximal wave power. Onshore refers to coastal areas where the water depth is 10 to 15 meters and the highest wave height is 7.8 meters, as the wave throw is ready to hit the bottom. Near shore are intermediate water zones with water levels ranging from 15 to 25 meters. It can be classified as deep water, intermediate water, or shallow water depending on the depth of the water. Offshore, the ocean depth is greater than 50 meters and the wave height can reach 30 meters or even higher.
Wave energy is a substantial renewable energy source with numerous distinct benefits over other renewable energy sources. To maximize the use of wave power, station operation must be optimized in addition to improving power conversion efficiency through innovative wave power generator design.
There are several advantages of using wave energy. To begin with, the energy is environmentally friendly. Second, the energy is non-polluting. The third point is that wave energy has enormous potential. Fourth, wave energy is a dependable source of energy. However, like with any viable energy source, there are drawbacks. The environment is affected by wave energy. Wave energy, like wind farms, might be an eyesore, causing clashes with the look of seas, which could affect tourism and local acceptability. The cost of wave energy is also a concern. Wave energy devices also need to be maintained on a regular basis, which isn't expensive.
Methodology. Design consideration. In order to determine the prototype's design, the researchers started the formulation of the wave electric power generating device design. The researchers partly conformed the design based on the methodologies and recommendations of various related literature according to the goals stated in the objectives.
The researchers created an initial design after extensive study, computations, and additional examination of selected related literature and prior researchers' wave power generator designs. As you see, the design of development in isometric view showing all different components and their respective placement in the design. The overall design of this wave electric power generating device is the formulated result and combined researches and suggestions to guarantee appropriate development and optimum efficiency.
In this figure, it shows the components of the design. The design stated components are buoy holder, rod, sprockets, bearings chain, and DC motor.
So here is the electrical component circuit diagram.
During the implementation, the researchers will focus on the most significant aspect of the project, namely the movement of the buoy in order to maximize the motor's rotational potential by utilizing wave. Every aspect of the design will be examined to make the design more effective. The researcher will troubleshoot any sections that aren't working properly. This is the end of our presentation. Thank you for watching and God bless us all.